Hello, welcome to Guidancee Education channel. In this video, we are continuing class 11 chemistry, chapter 2, atomic structure. We will see the topics that are discussed. Thomson's charge mass ratio experiment, Millikan's oil drop experiment, charge on electron, discovery of proton, Goldstein's experiment, production of anode rays and properties of anode rays. The content of this video is very important, so do not skip the video. Watch the video completely, and if you think the video is useful, like the video, share the video, and also leave your comments in the comment box below. If you have not subscribed my channel, do subscribe it now and also press the bell button so as to get intimated as soon as new videos are posted. Do not forget to see the questions added in the description box. Thank you. We will first discuss Thomson's charge mass ratio experiment. E is charge and Me is mass. It is slightly modified here. It has this cathode as usual and also this anode. At very low pressures and high voltage, cathode rays are produced and it passes through the hole in the anode. This is a setup to provide an electric field onto the cathode rays which pass beyond the anode. Using a magnetic field also can be provided. The electric field, the magnetic field, and path of the cathode rays are all mutually perpendicular. If there is no electric field or magnetic field supplied to the path of the cathode ray, it will pass on straight and then hit the cathode ray tube wall at B. This is point B. When an electric field was applied to the path of the cathode rays deflected and hit the tube at point A. That is, the bending was towards the positive electrode, suggesting that it carries negative charge. This experiment we have already done in the previous video. If you have not watched that video, click the I button in order to watch that. Okay. The experiment was repeated using magnetic field instead of electric field. Then also the cathode rays showed deviation and hit the cathode ray tube at point C. Please note the location of the north and south pole. This also suggests that the cathode rays carry negative charge. Remember, the magnetic field is from north to south. He repeated the experiment for different values of electric field, magnetic field, and magnitude of the charged particles in the cathode rays. He analyzed his observations and came to the conclusion that the deviation of the cathode rays depended upon three factors. One factor was magnitude of the charge. When the magnitude of the charge was increased, deviation also increased for the same value of electric field and magnetic field. Another factor was magnitude of the electric field. When the magnitude of electric field increased for the same value of charge, the deviation also in greater deviation for greater electric field for the same magnitude of charge. It also depended upon magnitude of magnetic field. Symbol of magnetic field is B. When magnetic field was increased, here E is increased, here B is increased, then also the deviation was greater. He repeated the experiment by providing electric field and magnetic field simultaneously, and when the values of electric field and magnetic field were balanced, then he found that the cathode rays passed straight and hit the tube at B as if there was no external magnetic or electric field. From this he understood that when these two fields were adjusted, their effects could be nullified. Throughout the experiment, the direction of the electric field, direction of the magnetic field, direction of flow of cathode rays were all mutually perpendicular. From these experiments, by carefully adjusting these conditions, he was able to calculate the ratio of electric charge to mass of electron, and he found that the value was equal to 1.758820 into 10 raised to 11 coulomb per kilogram. That is the unit. This is the value that he obtained. Mass is taken in kilogram, electric charge is in coulomb. That is why the unit is coulomb per kilogram. I hope it is clear. we will pass on to Millikan's experiment. Now we will see Millikan's oil drop experiment to determine the charge on an electron. Okay, after determining the charge on an electron, Millikan used Thomson's relation in order to find the mass of an electron. We will see the details. This is a diagrammatic representation of the device used by Millikan in order to do his oil drop experiment. Let us see the parts. The device was then called electrical condenser. Now it is called capacitor. Capacitor is a device to store electric charge. It consists of two plates, one which is positively charged plate, and another negatively charged plate. Charge is stored in these two plates, and in between these two plates there is a dielectric, that is an insulating medium. Here it is air. Now let us see the other parts. This is the atomizer. By working this, a fine spray of oil can be dispensed into this chamber in the form of a mist. This mist gets sprayed into the chamber and it settles on the plate, from where it passes through the small opening in the positively charged plate, and these oil droplets start moving down. In the meantime, through this slot, a beam of X-ray is passed into the chamber. Let me note it down here. These X-rays ionize air, which is the dielectric medium between the plates. And what happens? Cations and anions are formed from air. The oil droplets which are falling down acquire this charge and move down as charged particles. These falling particles can be seen using the micrometer telescope which is attached to the chamber. Please see the figure. The speed of motion of these oil particles can be adjusted by adjusting polarity, voltage, and total charge present on it. It is possible to accelerate or retard or even make these drops stationary based on these three factors. The falling oil droplets experience three forces. That is, they are under influence of three forces. First one is gravitational force. Second one, electrostatic force, because there is electric field between the plates. They are falling between the plates. Third one, viscous drag. It is oil. By viscosity, we mean its ability to spread. So, oil does not spread as easily as water. We say oil is more viscous than water. That is, oil experiences viscous drag. This viscous drag does not allow oil to spread easily. By adjusting these parameters, Millikan found that it was possible to accelerate or retard the oil droplets or make them stationary, that is, not moving. So he conducted experiments. He found out that the charge was approximately equal to 1.6 into 10 raised to minus 19 coulomb. This is the charge. Further, the mass of the electron was calculated by combining the value of the charge of the electron and also Thomson's charge mass ratio. Found that mass of electron, I will write it here, is equal to 9.194 into 10 raised to minus 31 kilogram. This is a very small value. 10 raised to minus 31 means 1 by 10 followed by 30 zeros. You have to divide 9.1094 by 10 followed by 30 zeros. So this value will become very small. That is why mass of an electron is considered as negligible. So this is a very classic experiment which helped to find out the charge on an electron, and from that, by finding by J. Thomson, the mass of the electron was also calculated. Okay. we do not need the derivation in our syllabus, so we are not going into the details of that. I will also now discuss discovery of proton. Now we will discuss discovery of protons. Rays containing electrons were called cathode rays. On the same line, rays containing the protons were called anode rays or canal rays. They are also known as positive rays. Goldstein in 1886 conducted experiments using a modified discharge tube and discovered protons. This is the anode, which is positive. This is the cathode, which is negative. These two terminals can be connected to high voltage. Zinc sulfide is coated on this wall. This is the connection to exhaust pump to reduce pressure. The discharge tube contains a gas. Under low pressure and high voltage, the zinc sulfide developed a green glow. So it was assumed that some invisible rays were passing from the anode towards the end wall of the tube, causing the zinc sulfide to glow. These rays were called anode rays because it was thought that it was produced from the material of the anode. The cathode is perforated. As the rays could pass through the perforations, it was called canal rays. Later on, the result of several experiments proved that the rays did not really originate from the anode, but it really originated from the gas inside the discharge tube. How did these charged particles originate from the gas? When it is connected to high voltage at low pressure, cathode rays started originating from the material of the cathode. The high energy particles of the cathode rays hit the atoms of the gas inside the discharge tube, causing the electrons in the atoms of the gas to get dislocated, resulting in the production of positively charged ions. Anode rays or canal rays contain these positive ions. In the case of anode rays also, different experiments were conducted with different parameters so that the property of these particles present in the anode rays would be understood. Now we will see the properties. Anode rays are also known as canal rays and positive rays. It has already been explained. They also travel in straight line, but the speed is less than that of cathode rays. Like cathode rays, they also are made of material particles. They are also deflected in electric and magnetic field. The direction of deflection suggested that the particles present in the rays were positively charged. The particles are positive ions produced from the gas inside the tube, and they are not formed from the anode. In the case of cathode rays, they are formed from the material of the cathode. Whichever material was used as the cathode, the rays showed the same property. But here, when the gas inside the tube was changed, their property also changed. The charge and mass of the material particles depend on the nature of the gas. So, the charge mass ratio also depend on the nature of the gas. For hydrogen gas, the magnitude of the charge and mass of the particle were the least, and this particle was called proton. That is for hydrogen. The charge of the hydrogen ions and mass of the hydrogen ions was minimum. The magnitude of charge of this particle was equal to that of the electron. So the charge and mass of the hydrogen ion is taken as unit charge and unit mass. Mass was found to be equal to 1.67 into 10 raised to minus 24 gram. Further experiments proved that electrons and protons are the fundamental particles. Later on, the presence of neutrons, a neutral particle, was also discovered by Cadby with mass equal to that of proton. For any other gas, the charge and mass was found to be a multiple of these fundamental particles. If the video was useful, do not forget to subscribe my channel and support me. Thank you very much. We will meet in the next video with the structure of